so Charlie, do I need to send this to your mom so she knows how much you talk in class?
Yeah. No.
Okay. But she'll have proof.
Oh, she already knows that.
Did you just call me dude?
No.
I think we can we can rewind the video and see. I'm pretty sure you did. All right. Slope-intercept form is y equals mx plus b. Okay. And what does the m stand for? That's the slope. And typically we describe it as something over something, and both words start with r. Have you heard it before? Rise over run. So if the slope is written as a fraction, the top number tells you if you should go up or down. If it's positive, you go up. If it's negative, you go down. So I'm going to write the top number tells me to go up or down. Up if it's positive, down if it's negative. The bottom number always tells me to go to the right. Always to the right. The only time I go to the left is if I don't have space. Okay? So up or down, always go to the right. What does the B stand for? The y-intercept. Okay. So if we're going to graph the first example, where should we start? 7. So we go on the y-axis and we count 7. And then this one is a fraction, 1 over 2. We rise 1, positive 1, so we're going to go up, and we run 2. So we're going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. When I run out of room, I can go backwards. So down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. And when we connect our line with our ruler, we make sure that we always draw arrows on either end of the line. All right, now one thing that a lot of students don't think about is that you actually have solutions on a straight line. You have points that are on that line that will make that equation true. Okay, so off to the side, we're going to write solutions. And we're going to pick some solutions that are on this line. So I'll start us off. One of the solutions is the y-intercept, that's the point 0, 7. If I plug 0 in for x, and 7 in for y, the left side of the equation and the right side of the equation are truly equal to each other, right? Because 1/2 times 0 is 0, 0 plus 7 really does equal 7. Okay, what's another example of a solution? Yeah, 2, 8. In the back. What'd you have? So 2, 8's another one, that's the solution right there. Is there another solution on the line? Negative 2, 5. So there's lots of solutions. Do they have to be whole numbers to be considered a solution? No. So if you wanted, you could pick a decimal number in here and then figure out what its y-coordinate is, and that would be a solution as well. So if someone were to ask you how many solutions are on a straight line, you would say infinitely many. I can pick any single point on the line, it's always going to be a solution, as long as it's on the line. Yeah?
Wouldn't it be negative 2, 6?
Yep.
Oh, no, sorry.
You're good. I didn't notice either. Perfect. All right. For the next one, we have our m and we have our b, but the m is written as a whole number. We need it to be written as a fraction. How do we do that? Put it over 1. Perfect. Okay, so where should we start? Start at 1. And then what do we do from there? Down 2, right 1. Down 2, right 1. Down 2, right 1. And then when we run out of space, we can go backwards. So up 2, left 1, up 2, left 1. And then once you've drawn your line, I want you to take a moment and I want you guys to write down 2 different solutions that are on that line. Anyone want to share a solution they got? Yeah. 1, -1. Anybody else? -1, 3. Yep. Perfect. All right. Standard form. Anyone know what standard form is? Yeah. So we've got ax plus by equals c. Maybe we'll learn Spanish by like osmosis. Wouldn't that be cool? Isn't that how like Rosetta Stone works? You like listen to it. Yeah. So we could learn it. All right. So there's two methods for graphing an equation that's written in standard form. One is called the cover-up method. Sorry, that's distracting. Would that be funny if I walked down there and just closed her door? That's distracting. I'll be right back. No? Yeah, no, I wouldn't, not to be mean, but just. Yeah. She came over at the beginning of the year and she's like, I'm really loud. I was like, I'm not, so. Perfect.
Oh, yeah.
Has she gotten mad at you guys? What did you do? Well, come on now. That's like every day. So I should watch you for prison, basically. I can do that, yeah. You're a changed man? Okay. Sure. So your next seat needs to be right there. All right, so the way the cover-up method works is you realize that we're going to look in this one for intercepts. So if I'm looking for the x-intercept, what do I plug in for y? 0. All right. So if I plug 0 in for y, then I have 4 times 0 is 0. So I'm going to cover that up because if I'm looking for the x-intercept, the y value is going to go away completely. Okay. So for the x-intercept, I'm going to solve the equation 3x equals 12. And when I solve that equation, what do I get? X equals 4. So that's the x-intercept for that problem. So I can go over 1, 2, 3, 4. There's my x-intercept. Why do you think it's called the cover-up method? Because it covered up the y. Okay. So now if I want to find the y-intercept, what do I plug in for x? 0. 3 times 0 is 0, so that's going to go away. And to find the y-intercept, I'm going to solve the equation 4y equals 12. Y equals 3. So a lot of students are uncomfortable when a linear equation is written like that, but they're actually very easy to work with. You don't get a lot of points, you just get 2, but that's enough to draw a line. So let's go ahead and connect those. And I won't make you find extra solutions this time, but if I wanted 2 solutions, what would be easy ones to share? Yeah.
0, 3, and 4, 0.
Perfect, yeah. 4, 0 is the x-intercept, 0, 3 is the y-intercept. Those are 2 solutions. Wait till we're done. Okay. All right, for the next one, if we tried to do the cover-up method, what would happen? So like this one would be good, right? Y-intercept. That one's good. What happens with this one? Yeah, it doesn't divide very well. It'd be decimals. Sometimes decimals are not as fun to graph. So with this one, we're going to do the other method, which is to solve for y. And when you solve for y, you're just getting the equation in y equals mx plus b. And that's totally fine. So if I wanted to solve for y, what's the first thing I would do? I want the y by itself. So what do I have to get rid of? The negative 2x. How do I undo that negative 2x and move it to the other side? Add it. So I'm going to say plus 2x plus 2x. So all that I have left over on the left side is negative 3y. On the right side, I have a 9, and I also have a 2x. What should I write down first? What would make it look like the form that we're comfortable with? I'd write the 2x first because that's what I'm comfortable seeing. So 2x and then a positive 9, so 2x plus 9. And then what do I have to do to get rid of the number in front of y? Divide. So I'm going to divide by negative 3, divide by negative 3, divide by negative 3. I'm doing that to everything. So these cancel. I get y equals, do I have to write it as 2 divided by negative 3? Anybody know? You can just take the negative, move it to the front of the fraction. A lot of math people will not leave it on the bottom. They just think it looks weird. So negative 2/3 x, and then what do I have on the end now? Negative 3. Okay, so we're going to start at negative 3. And then where do we go from there? Down to right 3. All right. Does that make sense for the notes? We kind of remember how to do that. Now we're a little less rusty. Okay, so your assignment for today, we're going to kill zombies again. There's a theme for the first 2 days. And so I'm going to put some equations on the board, and what you're going to do is you're going to graph the equation on this grid. And when you graph the equation, it's going to be like you're shooting an arrow through one zombie, and then you have to match the equation with the zombie that it kills. Okay? Do you like it? I think it's great. If you're going to just be graphing lines all day, you might as well have something fun to do with it. So when you figure out what zombie you killed, then you're going to write the equation next to the zombie below. Okay? Make sense? All right. So the equations I will have projected on the TV so you guys can use them. Would you mind handing those out for me? Thank you. Okay. We got to be ready now. All right. So for this one, we're dealing with inequalities. Do you guys remember what happens when you graph inequalities? This is the one where you shade. Oh, don't we love it? It means we get a color, you guys. I'll get the colored pencils out. It'll be so fun. So we have shading. Do we always have solid lines? No. What do we have sometimes? Dashed lines or dotted lines. Okay, so we're going to write the inequality symbols out just in case you have forgotten them. So this symbol means less than. This symbol means less than or equal to. Good. Less than or equal to. This symbol means greater than. This symbol means, oh, sorry, here we go. Greater than or equal to. Okay, which ones are solid? Which ones are dotted?
Solid ones are ones that are equal to.
Yes. And then the less than and the greater than are dotted. Or dashed. The reason that the other ones are solid is because if you think about the notes that we took on the front, we said that whenever you graph a line, the solutions are on the line, right? So solid lines have solutions. When you have a less than or equal to, the line has solutions. A dotted line would not include the solutions. That's why we draw it dotted. Okay. And then we'll get to the shading in a second. So if we look at this equation, how would you guys like to graph it? We could do the cover-up method. We could get y by itself. What do you guys prefer? Get y by itself? Okay, so how do we get the y by itself? I'm going to go ahead and write it over here maybe a little bit nicer. As far as the graphing part goes, you can put an equal sign in there because we only need the inequality for when we figure out where to shade. As far as graphing the line, we don't need the inequality. So what do we need to do first to solve for y? Subtract the 2x. So I have negative y left over. And then what should I write first? Negative 2x. And then we've got a negative 2 after that. Okay? And then how do I get the y all by itself? Divide by negative 1, divide by negative 1, divide by negative 1. So y equals 2x plus 2. Okay. So my y-intercept is 2. And then from there, I go up 2 over 1, up 2 over 1, up 2 over 1, and I go backwards. Okay, and then we look at the symbol, and so is this a dotted line or a solid line? Dotted line. And you guys didn't know this, but there's actually a baby animal that is in danger of becoming extinct. It is the baby sugar glider. And you know when a baby sugar glider... Yeah, it is. I would never steer you wrong. And do you know when a baby sugar glider dies? It is when you draw a solid line instead of a dotted line.
For real?
Yeah, true story.
Well, guess what?
So watch out. Watch out for those baby sugar gliders. All right. Now, does anyone remember from back in the day how you determine... Anyone remember from back in the day how you determine which side to shade on? Yes.
So with the negative 2, you shade anything that's under negative 2?
No.
Or shade, I don't know.
That would have worked kind of if it had just an X, not an X and a Y. Yeah. All right. Anyone remember? It has to do with the point 0, 0.
You plug it in for X and Y.
Yeah. So the point 0, 0 is on the right side of the line. Right? Okay. So on your notes, go ahead and write 0, 0. We are going to take 0 and plug it in for X and take 0 and plug it in for Y, and we're going to see what happens. Okay? So negative 2 is greater than 2 times 0 minus 0. And so now I've got negative 2 is greater than 0. Is that true or false? That is false. Okay. The shading has to be where points are true. So 0, 0 is false. That's on the right side. We can't shade there. So where should we shade instead? The left side. The other side. The not right side. Okay? Now, if I asked you for solutions that were in the region, what I mean is solutions that are in the shaded region. Okay? So what are some solutions? It can be any point that shows up over here. What's a solution to this inequality? Any point in the shaded. 3, 2's over here. Negative 3? Okay, so 1, 2, 3, negative 3, 2, that's a perfect solution. Okay, so I'm going to say solutions that are in the region. One example of that would be the point negative 3, 2. What's another example? Negative 4, 2. That's also in the shaded region. Negative 4, 2. Okay. For this one, since we have a dotted line, is it possible to find solutions that are on the line? No. So we're going to say none. There are no solutions on the line because this is a dotted line. Okay? So the solutions are in the shaded region. They are not on the line. Okay, let's do the next example. How do we graph? Oh, actually, before I move on, if you had shaded on the right side, guess what would have happened? You kill a baby sugar glider. Yeah, little flying squirrels. If you need to know, there's a picture up here of a baby.
They're not attack you, they fly.
Charlie, you're not allowed to speak. So if you shade on the wrong side, or if you mix up dotted versus solid, you kill baby sugar gliders. All right, so watch out. This is the day that things will get killed, okay? Because this is one that we mess up a lot, all right? So I'm watching. We're going to keep a tally. At the end of class, we'll have a moment of silence if we need to. All right, next one. How do we start? It's already ready to graph, right? It's y equals mx plus b.
So you
Start at 1, and then we do 1, 2, 3 over 1, 1, 2, 3 over 1. Is this a dotted a dotted line or a solid line? Solid. I like it. You guys will notice that I mess up when I speak often. So I guess you can make fun of me often if you enjoy that. Okay. Okay, so then we're going to take the point 0, 0, and what are we going to do? We're going to plug it in. So plug in 0 for y and 0 for x. All right, and we get 0 is less than or equal to 1, which is correct. That is true. And the point 0, 0 is right here. That's on the right side of the line, so where should we shade? On the right side. So if I ask you for solutions that are in the region, we already know that 0, 0 is there. Is the point 2010 in the shaded region? 2010. Yeah, okay. So it doesn't have to be on our paper to be an answer. We can kind of use our imagination for some of the answers, right? Okay. What about a solution that's on the line? Can we get some of those this time? Yeah. Okay, what's an example? 0, 1. Maybe one more. 1, 4.
5, 3.
Now, are you positive about that? Because we might have to... If you plugged in 0.5, it'd be 3 halves plus 1, which is 4 halves. It would be... Wait, 3 halves plus 1 is 5 halves. It'd be 2.5. So if you want to do 0.5, you can say 0.5, 2.5. Okay. All right, so we are going to go ahead and practice another assignment. Ms. Rice, so much math. I'm excited. Yeah, me too. This, I know. This is revealing who I am as a teacher. We're gonna do math. The day before Christmas break, we're gonna do math. Marvelous. You'll be making up the math. All right. This is our next assignment. This is you can't afford me. This is a person puzzle. The way a person puzzle works. Are you ready? You flip it to the back. You do the problem. Then you flip it to the front. And then you learn something about this woman whose name I can't pronounce to save my life. But you're going to learn something about her, okay? Do you know these answers? Yeah, so there we go. So you're going to learn something. No, you got to do the math. The part that I'm grading is the back. That's what I'm concerned about. The front is for educational purposes to broaden your horizons outside of math. Look at that. We're integrating learning today. We're doing math and history.
No way.
You're welcome, everyone. You're welcome.
I don't know what this is.